Alright guys, your essential question for today is, how do we solve trig equations and simplify trig expressions? Your vocabulary are inverse, arcsine, arccosine, and arctangent. Just a refresher, notice that we only use the inverse and arc trig functions whenever you're trying to find an angle. So that might come into play again today. You will have a quiz over this material as well as a test, but Thursday, don't know when it will be. I'll let you know when. Alright, let's just jump right into it, and let's look at an equation that I will ask you to find, or solve. It says, solve each equation, and I want the angle, or the answer, or answers, there should be more than one, to be between 0 and 360 degrees. Alright, so basically, this equation says sine of x is equal to the square root of 3 over 2. In other words, we want to find what values of x would work that if we found sine of that value, it would give us the square root of 3 over 2. Well, there's two ways of working this, and I'm going to show you the first one that you can do without a calculator. Okay, in order to do this problem without a calculator, we're going to have to rely on our trusty friend a smart trig class. The reason is because I want you to notice that this value is positive, right? Sine of x is positive square root of 3 over 2. So which two quadrants would have sine being a positive value? Well, the answer to that would be in quadrant 1 and quadrant 2. In quadrants 3 and 4, sine is negative, so my two answers cannot be in those two quadrants. Alright, so what I'm going to do is, since we're in quadrant 1 is one of those choices, what I want to do is I want to draw a standard triangle in quadrant 1 with a standard reference angle. And what I notice is that sine is opposite over hypotenuse. So opposite over hypotenuse would imply that the square root of 3 is my opposite and 2 is my hypotenuse. So here's my reference angle. So that means that this would be square root of 3 and this would be 2. Well, how would you find the missing side? Well, use Pythagorean theorem, right? So I'm going to have a squared plus the square root of 3 squared equals 2 squared. So that's going to give me a squared plus 3 is equal to 4. And that's going to give me a squared is equal to 1. So that means a is 1. Okay, now here's the thing. This doesn't look like one of those special right triangles that we learned. If you remember, those special right triangles all had a hypotenuse of length of 1. Well, you can make this a hypotenuse of length of 1 by simply dividing by 2. But if you divide this by 2, I'm going to divide all three sides by 2. See, 2 divided by 2 is 1, but key point here is, do you notice that now this appears to be one of those special right triangles? This is a half, so that means this angle is 30 degrees, and so this is square root of 3 over 2. That means that this angle is 60 degrees. And since that's the angle in quadrant 1, that's my reference angle in quadrant 1, one of my answers is 60 degrees. Now you're probably wondering, well, how am I going to get the second answer? Well, I noticed that it was in the second quadrant, so what angle in the second quadrant has a reference angle of 60 degrees? Well, one way to find that is simply take 180 and subtract the 60, so 180 minus 60, and that would give you 120 degrees, and that would be my other angle. So my two answers are 60 degrees and 120 degrees. Okay, so you're going to end up with two answers for these problems. Alright, now the second way to do this is using your calculator, and I'm going to bring up a blank sheet. Like, let's say you have sine of x is equal to the square root of 3 over 2. You're trying to find the angle, right? Well, if you remember, the way that you find angles is by doing the inverse trig function. So the inverse trig function of sine would be arcsine. So if I do arcsine on either side, then the signs will cross out, and so that would just leave me x is equal to sine inverse of the square root of 3 over 2. And what I'm going to do is I'm going to use that information with my calculator. But the issue with the calculator is that it doesn't give you both answers. Let me prove that to you. So my calculator opens, so let me get my screen. Alright, so we're going to do sine inverse, so trig, sine inverse, control divide, and so square root of 3 over 2. I gotta check. I'm probably not in radians mode, so let me go to a different settings, document settings. And I want to change this. See, it's in radians. I want my answer in degrees. Alright, so I'm going to hit make default and hit OK. Alright, let's try this again and see if I get the right answer. Hit enter. There it is. So this is 60 degrees. So if you notice, I did get one of the answers, but I didn't get both of them. Well, the way that you find the other one is, since you know it's 60 degrees, that again refers to that reference angle, so you have to look in quadrant 2 and find whatever that reference angle is also. So 180 minus 60, that'll still be 120. So either way you go, you're still going to have to remember a smart trig class, because you're going to need to know which quadrants you're looking at. There's always going to be two of them. Okay? Alright, so let's go to another problem. Let me go back to my PowerPoint, and then from current slide. So let's look at this one. Alright, cosine of x is equal to negative square root of 2 over 2. So again, let's do a smart trig class. So what two quadrants would we be looking at? We would only be looking at quadrants 2 and 3. The reason is because in quadrant 1 and 4, cosine is positive. So we're not going to be looking in there. Doesn't matter which triangle, which quadrant you pick. So I'm just going to draw me a triangle in quadrant 2. Cosine is adjacent over hypotenuse, so then that means that this is my angle. So this is going to be negative root 2 and the hypotenuse is 2. I'm going to use Pythagorean theorem to figure out what the other leg is. So I'm going to get a squared plus 2 is equal to 4, so that's a squared is equal to 2, so that means a is the square root of 2. Again, this doesn't look like one of my special rights, but I can make this by simply dividing everything by 2, and by doing so, I bet you can figure out what triangle this is. This is a 45-degree reference angle, and then 45-degree reference angle, so I need to find what this angle is. So to find the actual angle, this is 180 degrees, so 180 minus 45 would be 135 degrees, so that would be one of my answers. And then we knew the other one was in quadrant 3, so then that would be 180 plus 45, and so my other answer would be 215 degrees. So that would be my two answers. But again, let's try it with the calculator. So I'm going to do cosine inverse. So let me go back to the calculator. So let's do cosine inverse of negative square root of 2 over 2. And then that would give me 135 degrees, which is one of my answers. But the way you find the other answer is you'd have to find the reference angle and then use that reference angle to get your angle in the third quadrant. And that's how you get the answer for that. Alright, let's try another one. Cosine of x is equal to 1/2. So a smart trig class. And so cosine is positive, so I'm only going to be working in quadrants 1 and 2. Cosine is adjacent over hypotenuse, so this is going to be 1, this is going to be 2. Use Pythagorean theorem, so I'm going to have a squared plus 1 squared is equal to 2 squared, so a squared plus 1 is equal to 4, so a squared is equal to 3, so a is equal to the square root of 3. Again, doesn't look like one of my special rights, but I'm going to divide everything by 2 to make the hypotenuse 1, and that turns out that this reference angle is 60 degrees. So thankfully, one of my answers is 60. To find the second answer, I'm going to draw another triangle in quadrant 4 with a reference angle of 60, and so in quadrant 4, if the reference angle is 60, that means the original angle is 300 degrees. So my two answers would be 60 and 300. Alright, let's look at one more of these. Let's say I have tangent is, where is tangent negative root 3 over 3? So again, draw your A Smart Trig class. Tangent is negative in quadrants 2 and 4. So it doesn't matter where you draw your triangle, so I'm just going to draw it in quadrant 2. Tangent is opposite over adjacent. Watch how I label this. Negative root 3 over 3. One of these numbers has to be negative, right? Well, since this is to the left, this one is negative. So square root of 3 over negative 3, that's the same thing. Alright, got to find my hypotenuse, so I'm going to have negative 3 squared plus the square root of 3 squared equals c squared. So I'll have 9 plus 3 is equal to c squared, so that's 12 is equal to c squared, so c is equal to the square root of 12, which is the same thing as 2 on the square root of 3. Alright, this doesn't look like one of my special rights, but I can make it by simply dividing by 2 root 3, because then that makes my hypotenuse 1, but then you're probably thinking, well, wait now, this still doesn't look like one of the triangles we did. Well, you got to simplify. Look at this, root 3 over root 3, they cancel out, so that leaves an understood 1 over 2, so 1/2, so you know that this angle is 30 degrees. Remember, 30 degrees isn't your answer, you're in quadrant 2, so what angle has a 30-degree reference angle in quadrant 2? Well, that would be 180 minus 30, so that will be 150 degrees. So one of my answers is 150 degrees. To find the second answer, which angle has a 30-degree reference angle in quadrant 4? Well, that would be 360 minus 30, so that would be 330 degrees. And that would be my final answer. And I'm just going to double check because you heard me stuttering. Let me do tangent inverse with my calculator. So let's do tangent inverse of negative square root of 3 over 3. And fingers crossed, does that give me negative 30 degrees. Oh, whoa, whoa, whoa. You're probably thinking somebody done lied to us. But think about this for a second. Negative 30 degrees would be in the fourth quadrant, and negative 30 degrees, if I wanted to find the coterminal angle of that, add 360, that would give me 330 degrees. So negative 30 degrees is the same thing as 330, and that is one of the answers that we found, and so we'd use that to find the other one. So it does still work out. Okay, another type of problem that you might see is one that looks like this. It says evaluate the expression, assume that all angles are in quadrant 1. So when we draw these triangles, we can draw them as if they are in quadrant 1. Well, this one isn't that difficult because if you notice, it wants you to find tangent of tan inverse of 6 over 11. Well, one thing you should remember about inverse trig functions is that whenever you do the inverse of its trig function, they cancel each other out. So tan and tan inverse cancel each other out, so this is just simply 6 over 11. So that's not that difficult. One that might be a little bit more problematic would be this example, cosine of arc sine of 2 over 3. Because if you notice, cosine and arc sine don't cancel each other out. They're not inverses of each other. But just imagine that this arc sine is an angle, okay, because it's cosine of this angle. So here's my situation. Can I draw a triangle where the situation where my angle, where sine is 2 over 3. Remember, sine is opposite over hypotenuse. So if I label this with my triangle in quadrant 1, this will be 2, this will be 3. I can use Pythagorean's theorem to get the missing sides. That would be a squared plus 4 is equal to 9, a squared is equal to 5. So that means a is the square root of 5. And so now that I've gotten my triangle drawn, I want to find cosine of this situation. So cosine of this situation will be adjacent over hypotenuse, which will be the square root of 5 over 3. And that would be my answer for that situation. Alright, let's look at two more. What about if I wanted to find cosine of sine inverse of root 3 over 2? We'll again treat this as an angle situation in quadrant 1. Sine is opposite over hypotenuse, so the square root of 3 is opposite. Hypotenuse is 2. I can do Pythagorean theorem here, so a squared plus square root of 3 squared is equal to 2 squared, so that would be a squared plus 3 is equal to 4, so a squared is 1, so a is 1. And now what I want to do is I want to find cosine of this situation because cosine is adjacent over hypotenuse, so that will be 1 over 2. All right, last one, and then we will call it a day. What about tan of cosine inverse of 3 over 5? Again, treat this as an angle, a situation of an angle. So cosine is adjacent over hypotenuse. So this is 3 and this is 5. I can use Pythagorean theorem, but I know that this is going to be a 3, 4, 5 triangle. And so now with my situation drawn, I want to find tan of this situation. So tan is opposite over adjacent, so this will be 4 over 3. And that would be my answer, and that concludes today's lesson.